So the numerical is a beam 10-meter long is supported at its ends by hinges and carries a uniformly distributed load of 10 kilonewton per meter for a length of 6 meters from the left end of the beam. A counterclockwise couple of 50 kilonewton meter is applied on the beam at 2 meter onto the onto the left of right side support, right? So whenever you get numerical in words like this, you need to be very careful how he is describing the beam. So he is saying to the left of right side support, right? Draw the SFD and BMD of the beam. So first, let me go to paint where I have drawn the beam here. So this is my beam AD, which is 10 meters. 6 plus 2 plus 2 is 10-meter long, and it is hinged at A and B. I have hinges, right? You can show in whatever way you want. It carries a uniformly distributed load of 10 kilonewton per meter for a length of 6 meters from the left end. So this is the left end. From the left end of the beam for 6 meters there is UDL of 10 kilonewton per meter. A counterclockwise couple, right? Counterclockwise means anti-clockwise, ulta direction, of 50 kilonewton meter is applied on beam at 2 meter onto the left of right support. This is right support. D is right support. To the left of D at 2 meter, there is counterclockwise couple of 50 kilonewton meter. Now you have to draw the BMD and SFD for this particular arrangement. Now for all the BMD and SFD, what you have to first do is, let me move this to side. First thing you have to do is you have to draw this diagram representing the beam, and then we have to draw the free body diagram of the beam and find the reaction. So I have drawn the free body diagram of the beam here. Now I am not sure about the reactions, because whenever you have a couple like this which is acting on the beam, the reactions sometimes become in the reverse direction. So in all the numericals we have seen, reactions were vertically upwards on the supports. So sometimes it can be downwards also. So for time being I will not show the direction. Once I have calculated, I will show that. Okay. So now let us start finding the support reactions. So for finding the support reactions, what we will do is, we have, for equilibrium, two conditions need to be satisfied. The first condition is sum of all the forces acting on the beam should be equal to 0, and the second equilibrium criteria is sum of all the bending moment acting on the beam at any point should be equal to 0, right? So I will take the first condition, sum of all the forces acting on the beam is equal to 0. So using this condition I can write like this, RA, right? I'm assuming RA is in upward direction, plus RB, I'm assuming RD, right? Reactions at A and D both are in upward direction. So I will take that on one side, and that should be equal to sum of all the downward forces. Now there is only this UDL force which is acting in downward direction, and the magnitude of that is 10 kilonewton per meter into length, right? Length is 6 meter into 6. uh, the couple will not be calculated or will not be considered as force. Whenever you're doing sigma f, couple is not considered. This will be considered only in the bending moment. Even in the shear force diagram, couple is not considered. It will not have any effect on the shear force diagram or the sigma f formula. Now Ra plus Rd is equal to 10 into 6. Therefore, this will become 60 kilo Newton. Okay. Now I have to take bending moment at A or D. Any of the end I can take, and I have to find the one of the reactions. So I can find the other reaction. Now usual convention is I'll take bending moment at A. So for doing that, I need the sign convention for bending moment. So we will do that exercise we always do in our numericals. Draw a box like this. This is left side, this is right side, this is clockwise, this is counterclockwise. See, I have been teaching these subjects for last 8 years, and even now I always draw this so that I don't do any mistake in the numerical, right? So you also please follow this habit of drawing the sign convention so that you don't do mistake. Now left side clockwise is always taken as positive. So the the diagonal to that will also be positive. That is right side counterclockwise. And these two will become now minus, and this is also minus. Fine. Now I will start with the uh, bending moment, taking moments about point A. We get. Now let us start from the extreme right end. Now extreme right end, I am assuming the force in the upward direction. RD is in upward direction. So because of this, at A there will be a, you can see my mouse, this is counterclockwise moment. So RD into the distance is 10 meters, and right side, D is at right side of A, so right side counterclockwise, so it is positive. So RD into 10, so that is positive. Then I have at point C 50 kilonewton, which is counterclockwise, right side counterclockwise, that is also positive. So plus 50. Then I have UDL between A and B. So the total magnitude of this UDL will be 10 into 6. So 10 into 6. I'll put this in a bracket. This is my W. And I assume that this UDL, which is spread across A to B, is acting as a point load at the center of gravity, that is the mid of A and B. Now this is 6 meter, mid of A and B will be 3 meter. So I'll write it as 6 by 2. Now this is acting in downward direction. All the weights and forces are acting always in downward direction. So this is downward direction. About point A, this is making a clockwise moment. Right side clockwise is negative. So I will put here minus sign. So this is positive, and this is negative. So sigma m about A is equal to 0. So this should be equal to 0. Okay. Now when you solve this, you will get RD. So RD is equal to Let me open the calculator. 10 into 6 into 6 by 2 is 3, that is 180. This has come on the right hand side, so it has become positive. Now this 50 will come on the right hand side as negative, so it becomes minus 50, and RD into 10, so this will be by 10. So RD is 13, 13 kilo Newton. Now I have RA plus RD equal to 60 kilonewton. So RA is equal to 60 minus 30, and that is equal to 60 minus 13, 47. 47 kilo Newton. Okay. Now since both the reactions that I have obtained is positive, that means the directions what I have assumed is correct. I had assumed RA and RB both as upward, right? So if I get in this step the reactions as positive, that means my assumed direction is correct. If I get negative, then whatever direction I had assumed is wrong. It is in the opposite direction. Now let me complete the free body diagram. So I'll just put the force here, upward force, and this is another support reaction, and I'll just write that there. RA is equal to 47, right, kilonewton, and this is RD equal to 13 kilonewton. So we are done with the free body diagram, FBD, free body diagram. Okay, and this is the free body diagram for the given numerical. Now I have to start with the shear force diagram and the bending moment diagram. Now for drawing the shear force diagram, uh, I had explained in the previous classes very simple technique. First, draw a horizontal line which represents zero shear force, or this is the neutral axis of the beam. Now start always from the extreme left end of the beam. Okay. Now at extreme left end of the beam, I have a force which is the reaction force of 47 kilo Newton in the upward direction. So what I will do is I will draw a straight line like this. Now this line is representing me 47 kilonewton, whatever the length of it is, right? You don't have to take a scale like you do it for drawing a graph. 1 centimeter is equal to 10 kilonewton. You don't have to do all those things. Proportionately, approximately, you just draw it. Okay. So this value is 47 kilonewton, right? And the convention for BMD and SFT that we always use is positive force or bending moment is on the upward side of the neutral axis, and negative is on the downward side of the neutral axis. Now you have to see this free body diagram. We are mainly checking the salient points that are there. Now point A I have completed. Come to point B. In between point A and B, I don't have any force, right? There are no point force or point load, but there is a UDL, uniformly distributed load. So the variation of UDL, the shear force for UDL will be linear. It will go on increasing like this, right? Sorry, decreasing like this. Now, in order to draw that, what you have to do is You calculate the total shear force because of this UDL. Now the intensity is 10 kilonewton per meter. 10 kilonewton per meter into 6 meter will be 60 kilonewton. So the total shear force because of this UDL is 60 kilonewton. At this point it will be 0. At this point it will be maximum. So how to vary this? From this point you have to draw a inclined like this till it comes to minus 60. So what you do is you take your calculator like this. At this point I had 47 as the shear force. You subtract 60 from this. So I get minus 13, right? Don't do anything with the sign. Keep the sign as it is. Don't change anything here. So it is minus 13. Now come back to this diagram. Now this is positive and this is the negative side. Now let us say I'll mark a line here. Okay. Yes. This is representing 13 kilonewton on the negative side. So this is 13 kilonewton. Okay, now you join this point and this point using a straight line. The shear force variation is linear for UDL. Okay, you join this using a straight line like this. Now again you come back to the free body diagram. The next point is C. I have a couple here. I don't have any force, but there is a couple. So there is no variation in the shear force diagram. And between C and D also there is no force. So you draw a horizontal line between B and D. Couple will not be affecting the shear force diagram. SFP पे असर नहीं होता है. Now I have come to this point. Now here I have a upward force of 13 kilonewton. It is positive. So again take your calculator, plus 13, it becomes 0. That means at this point the shear force is varying from 0 to 13, and at this point it is varying from 0 to 47. Okay, so again I will draw another line from here to here, and I'll just write this is 13 kilonewton, this is 0, and this is also 0, right? And this is my SFD. This is, you have to write all these things. This is positive, and you have to show this is negative, right? So this is the section where my shear force is changing the direction and shear force is equal to 0, right? So this point represents the maximum bending moment on the beam. So we will have to find this location, right? So how to find this location? You have to use the similar triangle theory. This triangle is similar to this triangle. Now the length of this side is 47 kilonewton. The length of this side is 13 kilonewton. So 47 by 13 should be equal to this length divided by this length. Now I know the total length AB, right? Now if I call this as small x, so this will be 6 minus x, right? So using this logic, you will have to calculate this x, and at that point, what is the bending moment? That will be the maximum bending moment. Okay, so let us do that. So before that, yeah, so I'll directly write this. I think I explained this in the previous numerical. So 47 by 13 is equal to x by 6 minus x. So this implies x is equal to how much? Now let me quickly do it on my calc. 47 divided by 13 is equal to a divided by 6 minus a. Sometimes it calculates and sometimes it says it cannot solve on your scientific calculator. Yeah, now here it is showing me 4.7, right? So x is equal to 4.7 meter. I solved for x using this expression. I got the value of x as 4.7 meter. So I can find the maximum bending moment at that particular point. In your solution, you have to write SF at A is equal to on the left side of A is 0, on the right side of A is 47 kilonewton. At B, it is minus 13, right? And at D, it is minus 13 on the left side, 0 on the right side. And how it is varying, and what is the point where shear force is becoming 0. The sign is changing. You have to mention those things. I will post a PDF uh, soon on the dashboard, which will explain how to draw the shear force diagram, how to answer in your exams. Now let us draw the BMD, bending moment diagram. Now for finding the bending moment diagram, I need to first calculate the bending moment at all the salient points. Okay. Now let us start with this. BM at A is equal to BM at D, and that will be equal to 0 because it is supports, right? So the supports or the free end of the beam will always be having 0 bending moment unless you have a couple in the end. We will try to take a numerical if possible. If you have this couple in the end, then this will not be 0, otherwise it is always 0. Okay. uh, then
Sir, the answer is 5.21 x.
really
Yes, sir.
47 divided by 13, 5 point how much?
2-1.
5.21. Let me just check. 47 divided by 13 is 3.6. 5.21 divided by 6 minus, no, that's wrong. Check it again, please. Okay, it should satisfy this expression. Okay. 47 by 13 should be equal to x by 6 minus x. Now I have got 4.7 divided by 6 minus 4.7 is 3.6154, and if you do 47 by 13, you will get same, right? If you subtract that, you will get a 0. So you have to cross check. Did you get? Who was it asked the question?
Yes, sir.
You got it? You always cross check by substituting in the expression. Okay. And another thing is from the BM, from the SFD also it is clear. What you are saying is 5 point something. That means it should be somewhere here, very close to B, right? But it is quite far from B. But let's get back to the bending moment. Now, always start from um, the ends where you have the bending moment is 0. So it is easy for us to calculate. Then you randomly pick any point and you can find the bending moment. Now A is done. Let me go to point B. Now I have to find BM at B, right? So I will use the left side because I have only UDL and upward force. Here I have couple also, right? So both the sides it's more or less same, or I can take right side also, whatever you want, right? So BMB is equal to, now this is upward force, it is making clockwise moment on the left side, so it will be positive. So it is 47, that is the value of RA, into the perpendicular distance is 6 into 6 minus, now this force of UDL is acting downward, so it is making counterclockwise on the left side, so that will be negative, that's why I took minus uh, 10 into 6, so that will be, I'll directly write it as 60 kilonewton multiplied by, I'm assuming that it is acting at the midpoint, so it is 3 meters into 3. So this will be 47 into 6 minus 180. 10. Please mute your mobiles. Kilonewton meter. Okay. Now the important point is point C. See, whenever you have a couple in the problem, the bending moment suddenly changes on the beam. Okay. Some books give, clockwise positive, counterclockwise negative. There are many versions of this. So don't get confused with the direction. You don't have to remember which is positive, which is negative. In if you refer Ratan, R.S. Ratan, Strength of Materials book, I can share the soft copy with you guys. What he does is at this point he takes the bending moment on the left side and he takes the bending moment on the right side. So the left side bending moment and the right side bending moment will be different, and the difference between this should be equal to this couple. Okay, so let us try to do it that way. So I'll write like this: BM at point C on the left hand side. That is, this is point C. On the left hand side of the point C, what is the bending moment? So that will be, again it is these two forces only difference is the distance is different. Now it is 47 into, distance has become 6 plus 2 now. Instead of just 6, at C it is 6 plus 2. So 6 plus 2 is 8 minus 60 into, the distance is, now it is acting at this point. So from here to B it is 3 meters. 3 plus 2, so it will be 5 meters. Okay, so let us calculate this bending moment. 47 into 8 minus 60 into 5, 76 kilonewton meter. All right, now when I do it from the right side, I should get 76 minus 50, 26, right? So it's very clear, 13 into 2 it is 26, right? You should get that. So now BMC on the right hand side of C is equal to RD. RD is upward force. It is making counterclockwise moment, right? Counterclockwise moment on the right hand side is positive. So this is 13 into 2. So this will be 26 kilonewton meter. Now I have found at all the points. I need to find the maximum bending moment. If I do that, then I can draw the BMD. BM max is equal to, that is at this point, right? So I'll use this expression, 47 into this length is 4.7 x, right? So that is 4.7 minus, this is the intensity, 10 into 4.7 into, it is acting at the midpoint of 4.7, so 4.7 by 2. So let us calculate this. 47 into 4.7 minus 10 into 4.7 square by 2. So this is 110.45 kilonewton meter. That is the maximum bending moment. Now using this data, I will draw the bending moment diagram. So first draw a, before that just check, at A and B it is 0, at B it is positive, C also is positive, at C also right side it is positive, and maximum is also positive. Everywhere it is positive bending moment, so there is nothing on the negative side. So first draw a horizontal line like this. Now you will have to project, this point also. So I am projecting this point. This is the section where you will have the maximum bending moment, and maximum bending moment is 110. So I will just first mark this as 110, and at B, what is bending moment? 102. So it is very close to that, somewhere here. Then at C, it is 76 and 26. Let us say this is 76 and this is 26. This is 0 and this is 0. Now how to join? All the point loads and couples, it will be straight line. So from here to here it is all straight line. So let us do that first. So this is like this, then you get a straight line like this, then you get a straight line like this, and then from here to here it should be a parabolic curve, right? So you don't exactly need to draw a parabola. Don't use your engineering graphics skills here. You just use your uh, set squares and draw a curve like this, right? And you have to show that this is a parabola, right? So just write here, this is parabolic curve and these are straight lines, and just mention the values of the bending moment. So this is 110.45 kilonewton meter. This is 102 kilonewton meter. This is 76 kilonewton meter. This is 26 kilonewton meter, right? And here you write positive B, right? Bending moment diagram. So this completes the solution to the given problem.